Hello Edwin and everybody from Opticon. This is Professor Joe and I'm going to give you a little tour plus demonstrate the brand new Opticon Black Ace data control panel. But first let me give you a view of my office. Edwin, I think you'll like this. In my office I have two Recaro Ferrari racing seats hooked into a PlayStation 3 high definition TV, internet connected. Down into the hallway of my house, more importantly to you, is the room to the right. This is my build-it office. So give you an idea of the workstation that I have, both electronics and mechanical. This is an idea of some of the current projects that are going on here. So we'll go out, back into my office, back to my racing seats, and now down for the incredible Opticon Demo. So this is what I have. Up here is the Opticon Black Ace control panel. I'll zoom into that. This is completely configurable. To the upper left is the voltage of my battery pack, 12.29. That's the amp draw of the motor, the milliamp hours that I've used, and how many watts. Now this Black Ace Opticon controller is fed through an interface box. It is also connected to a standard LiPo 12 volt battery. It has a speed controller, this one is water cooled for the boats, into one of the new motors. Now this is a 2500 watt continuous motor, pull 160 amps. This is the one that I talked to you about and the one that we're using. It's a 4-pole motor, so it's extremely efficient. Even at high speed, the temperatures are very low. To turn on the speed controller, I have a switch, and of course I don't have an RC unit, so this little knob down here will permit speed changes and controls. So what I'll do is I'll turn the switch on. As I turn the switch on and I start adjusting my settings on my power panel, I should turn my motor on. The problem that I see right now is that unfortunately, oh there it is, I didn't turn the switch on. I guess that would help. I think the motor is going to jump around a little bit too much. So what I'm doing is, whoops, looks like this speed controller is not reacting. This is a new prototype controller, so we seem to be having a bit of a problem with it. So let me see if I can turn it on enough to recycle it. You can see the light going on in the side, but it needs some programming information, which I haven't done yet. Anyway, so much for that test. But what would display on this Opticon data display is everything connected with the motor. That would be the voltage, the power, the RPM. It can be used as a battery tank meter, so to speak, tell you how much reserve power you have. Now, into this data display unit, you'll notice that I have a bunch of connectors. So I can input about 12 different sensors, which are temperature, A to D converters, G-forces. If I have a link to the surface, then I can do GPS, I can do a video overlay. So the thing is extremely versatile in that regard. Now the motor itself is 5mm shaft, so I have these beautiful 5mm to 3/16 or 1/4 inch shaft connectors that go on there. So all in all, this is basically the system. Now if you talk about a heads-up display in a diver's mask, it's very difficult, if not impossible, to put it into the mask itself. So in this system, I've got my hand out of the lens, you can see what I've done. I've actually put in a 3-inch high-resolution color monitor on the side of this Alga mask. So the diver then can adjust the angle and move it out of the way. But you also notice the beauty about this is that it can ratchet in virtually any position that you want. Even the person that is on the other side, the partner, can view the screen if you want to, and you can clip it back in place. Microphone built into it, so a very effective system. Now, I built some smaller units. This went into a face mask that is just an ordinary diver's mask. We have a high resolution underwater camera on the left hand side that snaps off. And in this case, we have a much smaller monitor, but on the same type of bracket. So we can ratchet this in and out any way that we want. Now, if this is so close to the diver would generally not see that image clearly. So if you notice inside, there is an optic. And this optic is about a 6 to +10 diameter magnifying lens, and that allows the diver to perfectly view the monitor. Now, the last thing I'm going to show you is something that I've just developed that works absolutely terrific. I picked up some 10-watt linear LEDs. So you'll notice I have them in acrylic tubes on the side of this old wide-off full-face dive mask. These operate off 12-volt DC. This again is a prototype. These are filled with clear mineral water, so there's no way you can get saltwater intrusion. Again, this is just a prototype. The two lights are connected together. They go to a 12-volt battery, and the lighting source is incredibly flat and incredibly bright. These things come in 3, 5, and 10 watts, and in many cases 3 watts would be absolutely terrific. Plus, the beauty is you can take these off, and if you wanted to, move them to direct in a particular application. So this tied in with some type of a data display onto the diver's mask, tied into the special Opticon display unit. Let's give this one last try to see if it's kicked on. Now I have to do it again with a speed controller. Oh, there it is. It's starting to kick on. Can't make up its mind what it wants to do. You see the red LED onto it. No, I think I have to reprogram the speed controller. But the big thing is we can indeed provide this for you, and it can scroll through pages. Now, in order to set that up, this is the program that I'm using right now. This is on a little tablet PC that I have. I can do a live data display for evaluation. The unit is also recording the parameters that the diver sees. So it's not just a one-shot. We can play them for archival purposes to see the performance of the engine. So, hope that's giving you a bit of an overview, and I'll post this on YouTube right now, hoping that you can pick it up. Thanks, Edwin.